Hey guys, what's crack-a-lackin'? Somebody give me a 5 for 5 and we'll roll on to and through it. If you know what I'm saying. It's good to see everybody. Hope everybody can be here tonight. Gonna make it a fairly quick one, guys. So yeah. Please do all the YouTubey things like we always talk about, like, share, subscribe. Please hit the notification bell. Da 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 da. If you guys want to become a member, please do. I'm working on some stuff. I actually got a shipment of stuff in today, of some giveaways I'm going to be doing for everybody. They're decks of cards that some of them have been discontinued, and they're actually solar related, and space related and all that. Sunspots, what was the other one called? Starlink or solar system, and it's got moon, all kinds of cool stuff. So I'm going to be giving those, doing a little bit of a random draw, or even hey, answer a question, and kind of give it out that way. But if you would, guys, please share it out, and I do appreciate everybody that's a member, and everybody that's not. Best thing you can do is, hey, Ron, thanks, brother. Appreciate you, man. Way to start that all. I love that, man. Thank you so much. Guys, you don't understand how much I get humbled every time. It's something to see. You guys are just awesome. But yeah, so we're gonna go ahead and just jump into this and get the space weather stuff here. Guys, yeah, we're in a geomagnetic storm, and like I said yesterday, we had some stuff coming. Some of those halo things, halo eruptions that I was talking about, they are arriving, and they're arriving quickly. Um, this one here is I don't think it's not moving at breakneck speed or anything, but we are definitely in a storm right now. Now NOAA's forecasting a G2, which should, well, it should have already been a G2. Hey Sue Ellen, thank you, appreciate that. Awesome, thank you for the memberships. Everybody gets a membership from that. Somebody get in there and tell them hi, and thank you from Aaron and Sue Ellen. Thank you. Okay, so, oh shoot, I was going to show that video too, and I can't get to it. I keep forgetting to show the video that Shell sent me, and I keep forgetting about it. I'll show it in the next stream. It was of the eclipse, guys, and it got a big X of trails, we'll just call them, going across the sky. I've actually got the same picture. Very similar, looks very, very similar, but I'm in a whole different part of the country. So, just so you guys know, and I'm not saying anything on that end of it. It's just, that's the observations that we're making, right? So I'm not gonna, get into detail on that or anything either. But I will be showing that, Shell, if you're here. I apologize for not showing that already. I forgot, and and I'm not trying to make excuses or anything, but I've been sick, and it's just been a rough, and I'm okay now though, so I'm not gonna talk about being sick either. So anyway, thanks guys. All right, now X-ray production, you can kind of see how it just tailed off like very, very quickly, right? I'm not sure why, and why I say that is because we still have a large number of sunspots facing us right now. So yeah, whatever that means, I really can't tell. Are we going to get more activity? Yeah, we really are, and let me show you why. Right here's again, NOAA's forecasting is 60% chance of R1 or R2 radio blackouts. That is a M class flare. That's the M class flare range. All right, so it would be here on the M class flare range in this area. They're predicting a 10% chance of X flares, R3 or greater. And the reason why is because of all the stuff, right? That's what's happening. And we got all this stuff out there that's just firing at us. And yeah, a lot of sunspots, so it increases the chance, right? Hey Linda, Cemetery, good to see everybody. Now I know everybody's going to be going live about the same time right here, and I really try to work around it, but tonight I could not avoid it. I couldn't really put it off because I'm not sure what's going to happen later on. So just so you know, but if somebody else goes live like Marf or anybody, I don't care who it is, guys, go watch them and come watch me on replay, please. I really do appreciate that. I don't, you know, it's never my intent to put a viewer in the position of watching one or the other, right? So you're looking at a picture of the sun here, and it's showing the sunspots. This is back on the 28th of March. So if I just kind of grab the scroll bar here and we move it, we'll see the production of sunspots and how they have progressed here. See that? I see all these sunspots. Now, we'll probably take a deeper look here in just a second. But I do want to try to get up, let's see here. Let's see if SDO will load better now. Let's try. Hold on one second. We're going to try to load this up. A minute ago, it wasn't wanting to load. So, we'll see. Looks like it might be having issues. I don't know. For whatever reason, it's not wanting to load the movie tool. So I don't know. I don't know if we'll be able to show you the SDO imaging. I'll tell you what we can do though. Let's go ahead and pull up ISFA. And we can look at the same imaging over here. It just usually takes a little bit longer. But as that's loading, I'll show you guys some of the eruptions that's been happening. So this is Soho, and it is on a satellite a million miles closer to the sun, always looking at the sun, right? From our perspective, it's just a little bit closer to the sun than what we are. So if we go back a few days here, let's just go back to the 12th, and this is kind of when things started popping off. What we're getting hit with right now is probably this eruption. Okay, there's a halo signature that shows up here, and I'll pause it. Right about, okay, kind of there. You can kind of see it, right? All right, let me I'm gonna go down through here and just hit the update button on these. Okay, so give me 1 second, guys. I want this to be ready to go when I get over there for you guys. So let's do that. Do that. That's already loaded. Probably don't even need this one. So we're just going to stop that one. Okay. Now, so let's go to the 13th. All right. You're going to see more eruptions. Bam, bam, bam. Now, these are not massive eruptions. Not even in the grandest sense. These are not huge eruptions right here. Now, we do start seeing some bigger eruptions coming like those. Okay, this is on the 14th. Remember, there are a couple of halo eruptions on the 14th. Let me pause it here. There was one that kind of up this way. Okay. And then right about there was another one. Now I know that this is bringing it back a little. Okay. I'm going backwards here just so you guys can see this. So let me put it slower. Reverse. Okay, so here we go. Right about, let's go there. See that? That's a halo eruption. It's all the way around. Why do we see a halo? Well, this occulter disc is on the camera. That's on the satellite. Okay, it's a physical disc, so we can't see what's right behind it. So if something's coming right at us, because this is from our perspective, remember that. It's always as if you go outside and look up at the sun. So what do we see? Well, we can't see nothing behind that disc. So we got to try to figure out what's going on. Now, we used to have stereo A off to the side, where we could see almost a 90-degree difference, and we could see even quite a bit of the backside of the sun. That satellite is no longer out there. Give me 1 second, guys. That satellite is sorry. Wow, sorry guys. That satellite is outlived its lifespan. Okay, so with that being said, they brought it back to Earth. It's in Earth orbit and has always been. All right, but it's just been about 90 degrees off to our, well, we'll just say, yeah, 90 degrees to our left. Let's just use left, right. I'm not going to sit here and try to confuse people with directions in space. When you're looking at the sun, east-west is reversed when you're talking about that. That's just how the community does it. You have to pretend you're standing on the sun looking up. Okay, so it makes like looking at a map. If you had a flat map of the sun and you wanted to go east, you would have to go left. Okay, so just so you know. So anyway, let's go ahead and start this up. And we do start seeing some significant eruptions here, guys. Okay, these are significant ones. Now, not all of them are heading at Earth. There was another halo there. See, this is where it becomes very hard to forecast this stuff. Okay, so let me go to the next day. We'll go to the 15th, and we start seeing some. There was at least 2 decent-sized halo eruptions there. See this? That's a elongated one. Okay, so let me back that up, and that way you guys can see what I'm talking about. Now, they call these halo eruptions because it looks like a halo around this occulter disk. Also, remember, this is the surface of the sun, the white circle here. The occulter's there to block most of the light, and the reason why we couldn't get any imaging because the camera would be overexposed, flooded with light. So, yeah, so that's what's going on with that. Now, as I go forward here, you see that? Okay, that's a halo. Now, it is, like I said, elongated, but it is coming directly at us. So, thank you, Mary. I appreciate that. I'm going to take 2 seconds here to say hi to everybody. I'm not going to spend a bunch of time in the chat because I'm going to keep on the space weather. But I do want to do this in the middle once or twice. Probably once a video. That way I'm staying in touch with you guys. I'm a one-man show here, guys. I don't have anybody helping me. So trying to run all the technical stuff and everything else while I'm doing the video and talking to you guys, it gets kind of hard sometimes. Which is why the membership stuff is actually really cool, because I can just focus on you guys. But anyway, with that being said, if you guys could give me a roll call in there, that'd be awesome if I could see where everybody's from. And also, guys, if you guys start seeing the little Kool-Aid faces, that right there, the red Kool-Aid faces, those are the members. And most of you guys right here are. But those are going to probably start changing color here in the next week or so. And for people that go on to be, hey, Shell Spells, I'm going to show your video, I promise. I just can't show it today. I keep forgetting. I feel so bad for that. I really do. I keep forgetting about that. It's just like a 10 or 15 second video, guys, and it's showing, and what I'm going to do is I'm going to show hers, and I'm going to show mine. Because I got, it's almost exactly the same. It's amazing, Shell, just so you know. It really almost looks exactly the same. But anyway, if you guys could just, those faces, or some of those are going to start turning green, which means that now they've been members going on to the 2nd month. And then when you get to, I think is it 3 months, 2nd month, 3rd month, and then I think it goes to 6th month, and then it goes to a year. Those kinds of things, when you hit those milestones as being members, those faces are going to change. I just wanted to, yeah, it's kind of crazy, isn't it, Mist? Getting close, getting close. And please, guys, don't ever feel obligated to re-up a membership. I am not that man, okay? I don't want anybody to ever feel that way. So if I've ever said or done anything to make you feel that way, please just don't feel that way, because I don't want that to happen. And I'll be showing you guys those decks of playing cards I'm going to be giving out. My wife did an awesome job finding these. I mean, she's awesome. Yeah, she does most of the stuff for this channel, guys. I don't know if you guys know that or not. She really does. She is she's a beast. I'm telling you, she's awesome. Okay, so give me a roll call in there, guys. Where you guys at? I'm gonna keep moving, but if you could give me a roll call in the chat. I want to see where you guys are all from. Just regional. Hey, Ilea. Hey, Ripper, Stephanie, Miss. Hey, Miss V. Good to see everybody. Paluga. Okay, so I'm gonna keep moving. Now, this halo eruption right here, guys, is that's a decent one, right? But we can't tell how powerful they are just by looking at this imaging, right? There's another eruption. See that? So it's kind of elongated at a tilt. This one's coming at us also. These have not arrived yet. Today is the 16th going into the 17th. These will not arrive for another couple days. So we're looking at like double tap, triple tap type of stuff here. Maybe even more than that. We also got a coronal hole that's facing us right now. Now, don't get freaked out about that. I kind of talked about this yesterday. This is just the camera got probably overexposed, and it's just what it does. It's just a camera flaw. It tries to detect CMEs, so when it sees a massive amount of light, it does certain things automatically, and sometimes it just does this, okay? But just so you know, that's nothing to be like all crazy about. Okay, so those are the two bigger eruptions from yesterday. Now let's look at today, and you're going to see we got more. Okay, that one there, guys, I'm just going to say it. I think we dodged a bullet on that one. I really do. This is a very dense eruption. At least visually, it looks dense because cold shows up in darker colors on these. Okay, and the hotter it is, the brighter the image. So when you see it over here on the red, like this bright, and it's kind of more compacted in a ball, that it's very dense stuff. If that was to hit us directly, we are talking, you know, I'm not talking grid down or nothing, but I do think that that is significant enough that we would be seeing aurora very far south and north away from the poles. These are decent sized eruptions, okay? But again, I'm going to stress, it's not grid down. I'm not talking about that. You'll probably never hear me come on here and say grid down, because if that's actually the case, I'm probably not going to have a chance to tell you. Everything's just going to be done. And that's why I do what I do. I want you guys to be aware so you don't have to run over to Wages World channel or anybody else's channel to try to figure out what's going on. Because guess what? You're not going to be able to either, because you ain't going to have no electronics in situations like that. And again, we're talking, you know, that's a big thing there when we start talking about grid down stuff. But so these are the eruptions that happened today. Now, for those of you guys, oops, there's another one there. That's definitely not hitting us. It doesn't matter if it's going away or towards us on that one. It definitely is going way south, okay, of Earth. So it even looked like there might have been another halo right there, a partial halo. I don't think we have any imaging for today yet, or the 17th. It's just not enough time hasn't passed. Yeah, right here we have it. So if you guys come over here to seeds, all these websites are in my description box. So if I go down here, they will highlight, the tool itself highlights stuff. Hey, Butterfly, good to see you. Anna, good to see you. Yeah. The numbers were so wacky. Yeah. That's, yeah. Hey, 5G, thank you. Thank you so much for that. Hey, Shells, you got a membership there from 5G. Hey, Wendy, you did too. Ron, same to you. Comet, there you go. Angel, you got one. Hold it down in the Bronx for me, Angel. Heck yeah. But yeah. So thank you guys so much. Appreciate that. You guys have, I know I say it too much probably. You guys probably get tired of me saying it. But I'm going to say thanks to people that help. So, and I'm not going to try to like stay on that, but anybody that's a member, please turn your notification bell on. Anybody that's not, please turn your notification bell on. Hit the all, okay, so you know when I post. I'm trying to get it narrowed down to more of a specific time so you guys know when I'll be here. I understand sometimes I am out of that a little bit. Hey, thank you again. Appreciate that. Wow. Killing it again. Awesome. Thank you. Thank you. Hey, Vic, you got yourself a membership. Vicky, you got a membership. Heck yeah. She's been trying to get one. She has problems because of her technology. And she just got a gifted membership. There you go, Mama. That's what I'm talking about. She's my internet mama, just so you know. But please come to the membership streams. I've only done one. Okay, and I do post community posts sometimes on memberships, on the membership only thing. But it's not like, I'm not talking about big stuff. It's usually just typical housekeeping things in that end of it. Okay. But if you are a member, please come, because we're going to be getting really, really some cool stuff going on. I'm going to try to get you guys involved as much as I can. And I think you guys are going to really like what I got planned. So if you guys could just, hey Trish, I was going to ask you too, if you're still here. I know I said something about the email earlier in my last stream, but I didn't see your answer. Did you email me the other day? Because I want to make sure it ain't some crazy email. I didn't answer it yet. Didn't even open it because it didn't look right. So anyway. Okay, so. Hey, Kathy. See, where's everybody from here? A cop member? Okay. Scrappy Dappy Doo, good to see you. Texan, heck yeah. I know you guys are going to hate me for saying this. You're either going to love me or hate me when I say this. I am a Dallas Cowboys fan. Just so you know. Well, thank you. Thank you, Sandy. Appreciate that. But, okay, guys. Yeah, so you come down here and you can see where the eruptions are. And I'm sorry for jumping off there. I squirreled. Yeah, thank you, Kathy. You put that in there for me. Thank you. You're right. I was squirreling pretty bad there. I'm trying to get better at that, guys. And I am getting better. It's just taking a minute. That's all. Satellite is in geosynchronistic orbit. It's called SDO. All that means is it stays over the same part of our planet at all times and rotates with us around our axis. So it makes it stay over the exact same part of our planet all the time. But as it's rotating or orbiting around our planet at 15 degrees an hour, it will rotate itself in its eye to always look at the sun. All right. So I'm going to show you guys this one. This is the 171. Okay. This is right now. This is as we speak. This is very, very active in the sense of we have tons and tons of sunspots here. Okay. So this is solar maximum, guys. That's what I'm saying. If we're not in solar maximum right now, we are very close. So that's just what I'll say. Now, notice how these sunspots line up, right? I've explained why that is. I'm not going to explain that today, but you'll get two training lines of sunspots. Okay. And they'll slowly migrate towards the equatorial regions. Okay. And that is because of the sun cycle itself. A sun cycle basically is a magnetic pole flip on the sun. Okay, that's what that is. So and evidence of when that's going to happen is these sunspots start migrating towards equatorial regions. You guys probably have wondered in the past why we don't see anything on the equator of the sun as far as sunspots, at least not typically. That's why. It's because of all that. Now, I went in depth before on why a sunspot appears where it does. I went in depth on, how is a sunspot even formed. I'm not going to do that today because it does take a lot of explanation. But this is 2020. This is solar minimum. Solar maximum. Okay? So, do you see the difference? This is why we talk about solar maximum a lot. Because it definitely is more active. And there's why. Right there. Hey, Renee, good to see you. Hey, Nita, good to see you. Okay, so with that being said, you can see the eruptions. Now, this 171 is just a part of the light spectrum our eyes cannot see. That's all that it is. It picks out a specific angstrom of light, and certain gases show up in those angstroms of light. That's why we do this. That's why they do it, so we get a better visual understanding of what's going on. It helps our brains basically visualize what the data is showing. That's the whole purpose of a model, okay? Now, this is not a model. This is actually images that just has a filter on it. Now, you can do the same thing at home. You guys know that, right? You can actually buy these sun filters. You can put them on your camera. You could go outside and look at the same stuff. Now, a lot of that stuff gets to be expensive, and that's why most of us can't do that. Hey, Mir, good to see you. So there's been a lot of eruptions here, okay? A lot. So this is the 304. Now, the 304 is also another, same thing, right? Same part of light spectrum, that kind of thing. Now, I want to show you guys something here. This is just now happening. I've been watching this filament right here. You see this dark shadow? That is a magnetic filament. It's in the corona, and sometimes they lift off and explode out. Well, this one did, and that's a CME. Watch. See that? Now, I cannot say for certain right now, because this is just happening right here, if that one's going to come at us. It doesn't look like it erupted with like a massive amount of speed. And a lot of times, because of magnetics and gravity and other things involved, a lot of that stuff is actually recaptured by the sun. Okay? So it takes quite a bit of energy to get it to get out away from the sun. So that's my point on that. But you can kind of see. Now, a lot of people miss these right here because the sun's the background. It kind of camouflages the CMEs and things. So when things happen here on the limbs, we see it better. You see how you can see that, obviously. But if we go over here and we look on the limb, you can definitely see how much visual it gets. How much more. Right? Hey, Kay, thank you. Thank you for becoming a member. Something else on that end, guys, on the membership thing, too. I keep forgetting to say this. After you're a member for a month, each month you'll be able to, it's not a super chat, but you get to basically, say a highlighted message, and it'll tell people how long you've been a membership. It's like a super chat without super chat. Okay? So don't forget to do that if you're a member. Just go down and click the same button you would as if you're given a super chat. It'll give you that option. I just wanted to point that out. I think that's cool. And something else too. I know I'm talking about this a minute, but I'm just now figuring this stuff out. Okay. I think once a month I can actually give away a membership. I do not get to pick who that goes to. So anybody that doesn't know how that works, whoever's most active in the chat and somebody gets memberships, that's who gets the memberships first. The algorithm knows that. So that's how that works. We don't get a pick. But anyway, that is a lot of plasma, right? So, but we do see it better on the limbs. And that's why when we see stuff like that, you'll see a lot of people showing those, because it most definitely is more visual. But I want you guys to see this stuff too. Look, there's a filament down here too. It's very similar to that one. Now watch right here. It's going to do the same thing. This is what I'm talking about. You don't have to have a sunspot to have an eruption. And there it goes. Right there. There was nothing there. Absolutely nothing there. Hey, Trinity, good to see you, girl. You guys don't know her channel. Thank you for the membership, girl. Get over there. Get over to her channel, please. She does really good work. I'm telling you guys, get over there. Anyway. Well, thank you. Thank you for gifting one too, Trinity. My sister. Love it. She's my mod sister. Scary Gary got one. There you go. Heck yeah. Okay. So, with that being said, I want to show you guys, this one is the 211. So what do you got here? This is the coronal hole. It's just, the black is the actual surface. Hey, John, thank you for joining. Appreciate you. A lot. Thank you, John. Appreciate that. I am going to be doing a memberships only stream probably tomorrow. So everybody kind of look for that. I'm not sure exactly what time. But if you guys, like I said, just turn your notification bells on and you'll know when I do that. So, But you see how some of these eruptions, it does show the corona just rippling out. Okay, and you know, when we see these eruptions, this view really shows us really well this particular part of the light spectrum. And again, I have to say, this is why we look at different ones, because we see different things. So you see how that disrupted the corona? That is energy going across there. It's plasma. You got solid, liquid, gas, and then you got the fourth state of matter, which is plasma. All plasma is, by definition, is a gas that has a charge, negative, positive. That's all that it is. And that's how most space weather gets here, is magnetically. Okay, yeah, there is some other physics that gets it away, okay? But the majority of it is because magnetics. It helps steer things, and obviously gravity and everything else plays a part. Anything that has mass, gravity is going to play a part too. And so, well, you know, most things that have mass usually have some magnetics involved also. But even solar wind, like from this coronal hole, it gets here because of its charge. It grabs a hold of our connection line to the sun, and it funnels in that way. That's how it travels here. And it's kind of like a spring. If you could picture a string between us and the sun, and then put a spring over top of it, that's kind of how it travels here. Okay, it will travel on that spring. So the more compact the spring is, the more dense it is. So typically, yeah, a slower string will probably most likely have more of a denser impact, but a faster one typically will hit a larger area because of all the things that are involved. That spring actually will grow a little bit, the diameter of it will grow. So yeah, so I'll just leave it at that. But anyway, with the 211 here, that's the surface. The dark stuff is the surface. Okay, that's what that is. Now you can see these other eruptions. There's one there. We don't always get to see that. That's that last one I showed you guys from up here. Okay? So we don't always get to see that here on the 211. It's showing up this time, which is cool. So let me just pause that one. Now this is the 131. I show you guys this a lot when we're talking about flares. And again, you're going to be able to see more bright flashes and all that with this. Even that one. See that? So I'm not going to spend a whole lot of time on the 131 today, but I do want to show you the 94, because this eruption that happened on the northeastern limb of the sun over here was fairly significant. Okay, this is the one that misses us. Okay, the one I was talking about being dense. So let's see if we can see it here. Right about. Okay. It looks like we're missing some time here too. Hold on a minute. Yep, we are. And I noticed it over on SDO also, the website itself. So I think it lost some data somewhere. And what I'm talking about is, if you look at the timestamp, watch what happens here. Okay, now I'm going to go forward again. You see how the sun took off and moved fast? I'm going to show you why. Right there is when it jumps. Okay, you see the timestamp? It says 11:24, 12 minutes. You get 12-minute increments here, guys. It's like a flip book. Okay, so if we go 12 minutes, and it jumps like, what was that, an hour and 10 minutes. Okay, so we missed about an hour of data there. And that happens for a whole lot of different reasons, guys. It's just, most of the time it's just technical glitch. Okay, but I always find it amazing how we see this hang out in the corona on this particular angstrom. So let me back this up. Okay, now you guys see how it looks like a stinking twinkling Christmas tree? Does anybody else disagree with that? I mean, look at that. I mean, it's just, wow. But this right here, this is what I'm talking about here. Sometimes it'll look as though it just picked this stuff out of space and went that direction. What's happening is, because of the way we look at this, the technology we're using, it's only looking at that gas. So there might be something going on at all times up here. We just can't see it because of we're looking at a specific light angstrom, okay, angstrom of light. So when these particles start to travel, they travel on these magnetic lines on the sun, right? So every once in a while you'll see it and it'll look like it just picked it out of dead space, and that's not what happened. So, and a lot of times you can show people this by showing them like this one here and then going to a different angstrom, and it'll look totally different. So we got 944. Oh heck, we're real close to that right here. So let's just take a look at it here. Okay. You see how that didn't even look close hardly at all to what the 94 angstrom looks like. So I want you guys to understand that. Now you actually get to see what I was talking about here. Watch right here. See that? See how it just kind of lit up? It wasn't connected at the sun. It didn't move from the surface on through, right? You can't see it. Now, it most definitely did. Okay, we just couldn't see it. So, look at that. Okay, there's that jump in time again. Now, back here on this one, we'll take a look at that again just so you guys understand what I'm saying. Okay, so, and also guys, I was looking at the 335 angstrom? I don't show you guys that one hardly ever. Okay, and you know what? I think I'm going to show it to you right now because I think I need to. And the reason why, and I'm not sure if anybody else is going to pick up on this or anything, but I want to kind of get out ahead of this and let you guys know what's going on with this, because I don't want people to get confused on what's happening. Okay, do we have a... Yep. All right, here we go. I don't show you guys this one very often because you get this checkered board look, and it's just from the technology, guys. That's all it is. So you get this kind of like checkered pattern, and it's the camera itself causing that. So what I'm going to do is I'm going to load this up, and I'm going to show you guys. Well, turn the movie tool on first. What it's going to look like, it's going to look like something shot at the sun, okay? Because, and before I go any further, I'm going to show you what I'm talking about. I almost was just kind of ignore this because most people wouldn't catch it anyway. But just in the chance that somebody does see it, I want to show you guys exactly what's happening, okay? We're going to let that load, but while that loads, we'll go look down here at the magnetogram. And the magnetogram, again, it's just another way that we look at it, the sun, okay? And these are the sunspots. You got negative, positive, right? Red, blue, that kind of thing. I've talked about that a lot. When we start seeing them get complex, what I mean by complex, you start seeing individual cores that are negative and positive, right, on the surface, and they start intermingling. When they do, and then when they finally connect, it's a reconnection. When that reconnection happens, that's when it flares. Okay? So it is a very, let's just say, well, it's actually kind of violent, to be honest with you, when that happens. And that's why the flares cause CMEs. And it's important to understand the difference between the two. Flares are measured by X-ray. That's it. Okay? A CME is actually highly charged particles, plasma, that hit us, that get ejected from the sun. That's a CME, a coronal mass ejection. Coronal means the corona, the atmosphere. Mass is exactly what that says. Ejection, exactly what that says. Now, the right technical word for those would be interplanetary coronal mass ejection. That's what we get hit with, okay? Because it's interplanetary. It left the sun. It's going out towards the planets. Now, everybody just calls them CMEs, which there's no harm in doing that, but technically it's the wrong abbreviation. It really is. So when you say CME, it's coronal mass ejection, which means you can have a coronal ejection, right? But the sun will recapture most of it. It doesn't go out into the planets, into the solar system. So just to kind of give that kind of an explanation there. But as you can see here, guys, when these start doing this, they just start bam, 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 fire, 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 fire. This one here is getting active. It was active over here. Now it's over here. We got one trailing over here that's doing the same kind of thing. These are big coronal prominences. What that means is just an active area of the sun. That's a large area. So when these start intermingling like this, they become very active and become very volatile in the sense of it can flare at any second. Okay? And we're seeing evidence of that now. So I'll just say that. And again, look at this. Look at these, man. I mean, it's like you get so many sunspots, you don't know where to say cut it off at, you know? It's really crazy. So when you're trying to focus or forecast these things, which is why I don't forecast, I nowcast. I show you what's going on right now. Because, you know, when I'm forecasting, I'll try to go out 1, maybe 2 days, but I will not go any further than that. And the reason why is because 99% of the time, I'm wrong when it's the 5th day, right? So, you can see the course here I was just talking about. See them? This is a really good way to show you guys. Now, when these start getting closer, the reds and blues start mixing. That's when you really have to watch them. Now, it doesn't mean that this one here, you know, it doesn't look like it's unstable. It doesn't. That thing can blow off at any time too. But the chances are greater when you start seeing them like this. That's all I'm saying. Okay? So you can see how the red and blues are getting close to each other. They're starting to bleed into one another. And I'll be interested to see what this one looks like when it gets about here. But these are, all of these are going to be, if they're not facing us now, they will be very shortly. Okay? Now, this is just a black and white difference image over here, guys. It's showing us the same things. It's just in a different visual. Okay. So let's go up here to the 335 and see if I can. I want to show you what I was seeing. I actually recorded it on my phone, and I wanted to show it to you. There it went. Okay. Now we're going to see a bunch of these. Okay, because it happens more than once. I want you guys to look over here, and again, please. Let me finish what I'm going to say before you draw any conclusions, okay? And I'm not telling people how to think. You guys can think whatever you want, but I'm going to give you my opinion on what's going on here, okay? So, we're going to watch a flare right here, basically. Actually, I'm just going to roll this back, okay? Okay, so I'm going to back this up. Okay. So you see that, right? Obviously, everybody can see that, right? Now, where's that coming from? That's the next question. That's what most people would ask themselves. What the heck is that? Right? Because it looks like something just when a big triple beam hit the sun, right? But I want you guys to see something, because in my opinion, that's not what's happening. And I'll show you why. Let me back it up. So if we go, and again, this is that sunspot. Okay, so if I take it to the image right before, you can kind of see where it started to flare already. So when it went ahead and flared, you know, how can I tell you that it flared? You can see it. it shows up that little hashed X pattern. Okay, so what happens here is that's how the camera visualizes it. All right, picture it like this. Say you went outside. I remember doing this as a kid. Okay, when I was a kid, I'd get in the car with my mom and dad at nighttime, right? And you know, kids do what kids do. Well, back when I was a kid, I could climb up in the back of the window well in the back seat, and the cops didn't care, right? And most of us are my age or a little bit younger, probably maybe 10 years younger. I don't even know if it would go that far. But anyway, you probably remember doing those kinds of things, and nobody ever looked down on that kind of a thing. But as a kid, I would do that. I would climb up in the window well in the back seat, and I would start looking at the street lights that were flying by, right? And I would squint my eyes. Okay. Now I know I'm telling you something that most of you guys have probably done, right? But I vividly remember doing this as a kid. And you can take that single light source as you're closing your eyelids and squinting at it, and you can stretch it out into a big long line, right? That's exactly what's happening here with the camera. Okay? So that's what I'm trying to tell you. And that's why you see it like that. You can kind of even see it going this way if you look down closer here, because it didn't just go one direction, right? You can see how it continued on. So with that being said, most people are going to look at this and they're going to think it stopped right there, and it looks like, hey, the sun just got shot with something and caused the flare. And I'm not saying that ain't a legitimate thought to at least observe and look at it. I'm just saying that once you understand what I just said, I hope that you have a little different opinion here. And the reason why, can you guys see those three lines? They line up exactly with these. So it didn't stop there. That's my point. It went on through. So if that was like shot there specifically to cause a flare, that ain't what happened. Okay? And I know that and it's my opinion. You guys are welcome to have whatever opinion you want. And I'm not going to think any less of you. Okay? I really am not. I promise. But what I think is going on there is that. And for all those reasons I just said. You know, I'm sorry for the kid analogy and all that, but is what it is. So, okay. And it happens more than once, guys, here lately, because of a lot of flares. See that? There's one there. It happened again over there. And right there. Okay? This is even better to show you what's actually happening. I should have showed you this one. I didn't notice that until just now. Okay. Oops. So, we're going to be looking right here. Watch this. See it starting to get active already? Starting to move around? Flare. Right? I mean, it starts to happen before that even hits it, is what I'm trying to tell you. So if we go forward here, so bam, flare, there it goes. So, and again, like I said, guys, I'm not going to have any feelings towards anybody that don't agree with me. That's cool. I mean, it's just my opinion. So this is what I would say. Hey, Dan. All right. So what can we expect? Well, guys, what we can expect right now is more geomagnetic storming. It's going to continue on happening. Now, let me show you a CME tracker that it's fairly new. It's called Zeus. Okay, I showed you guys this before, but only a couple times. So let me, that's the latest one. You can see the date here, right? So at 16, today at 7 UTC, that's when it's seen that. All right, you can see it down here as time goes past. And it's telling you what day right there. See? So, in my opinion, this one here is actually a little better than the other CME tracker I've always showed you guys. Now, you got other data here too, and I'm not going to go into all that. But you got the shock speed, the compression ratio. You know, I always talk about compression and rapid expansion. It's touching on that. And it talks about the maximum energy. Then you got the BN, and I'm not going to go into what that is. But, so let me hit that. And we'll let that load. So I'm going to pause it, and you'll see that it goes to a date. Notice the model doesn't stop, but the slide bar does, because it goes to that date and stops. All right, so if we go the next one, there's that one. That's on the 12th. Okay, that happened on the 14th. See that? It's showing it hitting us. Then there's one on the 15th. Another one hitting us. 16th. Maybe a glancing blow. Okay? And I also love the fact, I want you guys to look at this. Because I just noticed this the other day. I didn't even know that they were showing it like this. See this line? That's a magnetic connection line somewhere. I don't know where. I really don't. So I don't know where that's coming from. So and if anybody else knows, let me know. But that's an interplanetary magnetic field line. At least from what I can understand of this. Here's Earth. Our connection's here. Right? And it is showing, I didn't notice that either. Yeah, it's showing movement and fast, and wow, this thing is more detailed than I thought it was. Huh. I'm going to have to learn more about that model, guys, before I'm confident in what I'm telling you guys, okay? But what I can show you is direction, okay? So, yeah. Now, I'm going to go ahead and do that. Click off of that. Now, what we're going to do is I do want to stop in here at spaceweather.com. I haven't looked at this yet, so the overdue CME finally arrived. Okay, this is the one that popped off on the 12th, I think, and everybody thought it missed, including me. Okay, I thought it missed. But it looks like it was probably just moving slower than what we all thought, and it finally hit. So, with that being said, G1 class storms, all this other stuff, plus we've had a bunch of other CMEs fired at us. These are Aurora, guys. Anybody doing Aurora photography? Better hit it. Philea's in the chat. Thank you, sister. Love you. For real. Hey, Lisa. So, yeah, guys, I mean, yeah. Aurora is awesome. So, that's one of the best things about this. Now, when I say we had a lot of sunspots, I was not kidding. Look at this. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. That's a lot. During solar minimum, to give you guys a contrast, we will have months go without having a sunspot facing Earth. Okay? So, when I show you this, I'm not kidding. That's exactly what's happening. There are no sunspots here. That's how they, well, even over here at spaceweather.com, he actually maps it. You see this right here? This chart here, or this, I guess, list, if we want to say that, you can see, right? In 2024, how many days have we had without a sunspot facing Earth? 0. 2023, same thing. 2022, we only had 1 day. But check this out. 2020, which is what this is, okay? We had 57% of the days that year, no sunspots facing Earth. That's 208 days. 281 days in 2019. So, you know, this is a really good reference to come to when looking at that stuff. So, just so you know, uh, if I missed 5G, I want to say thanks again. I'm not sure if I missed that last one that you donated. I really appreciate that, donating the memberships. It's awesome. Yeah, that's awesome stuff, isn't it, guys? I'm not going to read the articles here, okay? It's not that I can't. It's that I want everybody to go over here and give Dr. Tony Phillips some love. This is his webpage. I don't know him. I've never ever even had an email conversation with him. I just think this is an awesome site. Okay? It's concise. It's right there. Way more concise than I am. I guarantee you that. But yeah. Yeah, I'm not going to talk about this here. This is a lot of explanation here. The Doppler shift from the solar eclipse, I'm not going to go into that. Guys, please come over here and read that. It's very interesting, I'll tell you that. I've read up on it before. But if you keep scrolling down, these are fireball reports. These are actually reports of fireballs that people actually call in, right? If you see a fireball, you can call them and tell them, hey, I seen a fireball. All this stuff is here. Now I want to bring this into the light a little bit too. The near Earth objects, near Earth asteroid, NEA, right? What do they consider near Earth? I don't know. Well, let's see here. No, that's not. We're not talking about a PHA, potentially hazardous asteroid. That's not what a near Earth asteroid is. Okay, I think they're different. Could be wrong, but they are different, I'm pretty sure. Not 100% on that, but none of the known PHAs is on a collision course with our planet, although astronomers are finding new ones all the time. And that cannot be stated any more powerful than that. I'm telling you. And what I'm saying that is, it's just like Billy Bob Thornton in the movie Asteroid. He said, begging your pardon, Mr. President, it's a big-ass sky, right? I mean, it is. It's huge, right? So you can't expect to see everything. Now, oftentimes, if you guys come over here and you look, you see the year here? That's the year they're discovered. It's not just because we're currently in 2024. If you scroll down, you're going to find a few that aren't 2024. Maybe. Here's one. 2017. That's when that one, they discovered that one. All right? And it's back. Okay? It's on an orbit, right? Or I guess it's not really in an orbit. I misspoke there. Sorry. It's coming in. All right? So they discovered it back in 2017 wherever it was at. And now it's within 3.8 LD, which is lunar distance. The distance between us and the moon. Okay, that's how they measure these. Now they're talking about a PHA up here, the particularly hazardous asteroids. Those are measured in astronomical units. Now an astronomical unit is the distance between us and the sun. Okay, it's roughly 93 million miles away. It's not exact. So if you're trying to do really good calculations, and you're already going to know what I'm saying here. You can't just use 93 million miles. You have to find the exact distance there to be, accurate. But as you can tell, guys, when they light these things up in red, I want to point this one out. You see this? 2024 GL2. It was discovered on April 11th. Okay, so that makes it what? 5-6 days ago? Right? Well, see that? It says 0 LD. You know what that means? That means that was really close. If not, came into our atmosphere. It may have burnt, it may have hit. It may have been in our atmosphere and burned up like a meteorite, okay? That happens sometimes. But I want to point something out. Here's your speed, right? Because there are a whole lot of things have to be considered here. So speed is one of them. right? And that's not breakneck speed. I've come over here and seen them in the hundreds. Okay? But the biggest one to me when talking about this is the actual size of it. It was only 3 meters. Okay? That is very, very small with what we're talking about. Especially when you compare it to this one. 600 meters. Okay? Now, I don't know when that one was discovered. It doesn't have a year in the front of it. I don't know. Neither does this one. So my guess is these were discovered a very long time ago. I can't say for certain, but that's what I take from that. But I think it's interesting. So come over here and check this out. Give him some love, Dr. Tony Phillips. You know, he does these. This is NOAA's forecast too. See, he goes down through here and he posts it here also. So mid-latitudes. What's mid-latitude? People ask me that all the time. It's just closer. It's not in the equatorial regions of Earth, and it's not in high latitude, which would be the Arctics. It's in between. It's where most of us live. Okay? So when you start talking about magnetic storming, we get different levels of storming depending upon where you're at on the planet. Now, overall, it's basically the same, okay? Unless you're on the North or South Pole, because that's definitely going to be a little stronger there. That's why we see aurora there also. One of the reasons why we do. But they go down through here, and he gives you at high latitudes. They're saying a 10% chance of active, okay, and then mid latitudes active is 40. So people have asked me, how can that be? How can it? Well, it's just the way that it works, and because things hit and they come into our system in different ways through cracks and everything else. Now, let's see here. So, but you can also see when you're talking about chances of severe, you're looking at 50%. Now, I also want to say this too. The reason why that this is 10 and this one's 40 is because they're expecting it to be stronger than active. Okay? Not because of the chance of something happening. They're just basically telling you how active or severe something is going to be. So the chances of having a storm like that be active at high latitudes is only 10%. But the same storm hitting us, there's a 25%, it's minor. And a 50%, it's severe. Right? So I hope I explained that well enough. Hey, what's going on there? Good to see you, Leisure. See you, Butterfly. Thanks for stopping in. I know this is a long one, guys. I apologize. I wanted to get all this out to you. But, okay. So, I wanted to bring that all to you guys. I'm not going to go much longer here. I've gone way too long anyway. We're over an hour, and I'm trying to keep it under that. But, if you guys are members, anybody gifted memberships tonight, thank you so much. Get over and watch Marfugal. I bet he's live now. Yeah, 11:07. I got so he's live. Get over there, guys. I love all you guys. If you're a member, turn that notification on. I'll see you guys tomorrow. I'll be back here giving you guys updates as things happen. During events like this, we're expecting a bunch of stuff. I'll probably stream more than once a day once the stuff starts happening. Just so you know. But anyway, guys, God bless. Yahusha saves, and you can drink this Kool-Aid.